Hey guys, this is Ankit and welcome to the Google Cloud Platform Task series. We are doing a list of basic tasks to get ourselves familiar with Google Cloud Provider, that is GCP. We are following the DevOps Engineer and SRE learning path, also available at cloudskillsboost.google/paths. You can always refer to my repository, thecloudterminal01/learn-devops to get more details. For today's task, we have the following objectives. We will first install Anthos Service Mesh with tracing enabled and configure to use Cloud Trace as backend. We will deploy an Istio-enabled multi-service application, enable external access using Istio Ingress Gateway. We will evaluate service performance using Cloud Trace features within Google Cloud, create and monitor service level objectives. Finally, leverage the Anthos Service Mesh Dashboard to understand service performance. The total amount of time we will be spending will be around 13 to 15 minutes. So let's begin. Let's start with our first subtask. We will install Anthos Service Mesh with tracing enabled. For that, first let's set up the environment variables. So I'll run this in the Cloud Shell. Now to configure kubectl to manage our cluster, let's run this command. Now we can run kubectl config view, which works. We can run kubectl get nodes as well, which works. We can also run gcloud container cluster list command to check that our cluster is running. So over here we see that number of nodes are 3, same information which we got using kubectl get nodes. Now let's run commands to install Anthos Service Mesh. We will give execute permission to the file. Now we'll use ASM CLI to install Anthos Service Mesh. Let's wait for this to complete. The installation is complete. Let's enable Anthos Service Mesh to send telemetry to Cloud Trace. For that, we will be running this command. Now let's go ahead and install the microservices demo application on the cluster. We'll be installing online boutique application. This consists of 10-tier microservices and it's web-based e-commerce app where users can browse items, add them to cart and purchase them. Now Google uses this application to demonstrate user services like Kubernetes, GKE, etc. First, we will enable Istio sidecar injection. So for that, let's go ahead and run this command. Now we will enable Google to manage our data plane so that the sidecar proxies will be automatically updated. We will annotate the namespace with managed to true. So let's go ahead and run this command. Finally, we are going to install online boutique application. This is the GitHub repository for the same. You can go ahead and check out the repository yourself. So I'm going to go over here and run these commands to install the application. Let's patch the deployment of product catalog service with this label version 1. Now, in order to be able to access the application from outside the cluster, we will install the Ingress Gateway. For that, we'll be running these commands. Let's clone Anthos Service Mesh packages. And finally, let's apply the manifests present in Istio Ingress Gateway folder. Now let's run the command to configure the gateway. Now we have deployed all the pods and services. We can go ahead and check. These are our services that we have deployed 3 minutes ago, and the Ingress Gateway as well, which we deployed almost around 104 seconds ago. So let's go ahead in the Kubernetes console and check the workload from there. So these are the list of microservices that we have deployed in the default namespace. Let's go to services and ingress section. This is the external load balancer IP which we can use to access the application. So let's click on this and we can go ahead and browse through the online boutique application. We can also go to CloudTrace to view tracing information for the different microservices. So this is the information available in the default dashboard. We can click on any of the dots to get more detailed information corresponding to that event. For example, this one corresponds to frontend.default.svc.cluster.local. We can click over here as well to get detailed information corresponding to this event. For example, this one corresponds to product catalog service.default.svc.cluster.local. Now let's go ahead and deploy a canary release that has high latency. For that, we will be cloning this repository into Istio samples directory. So we have cloned the repo already. Let's create new resources on the GKE cluster. We'll be deploying these three: destination rule.yaml, product catalog, and vs split traffic.yaml. So I'll copy this and apply. We can actually go over these files as well. For example, destination rule.yaml has the following content. It's used to set routing of requests between two service versions. Previously, if you remember, we deployed our product catalog application with version v1, and just now we have deployed the same application with version v2. And this particular YAML has the following content. So over here we have a Kubernetes resource of type virtual service, and we are splitting traffic between two versions of product catalog services, version v1 which gets 75% of traffic, and version v2 which gets 25%. And if you see in version v2, we have set an environment variable that adds high latency to your requests. So let's cat this and grep for latency environment variable. So over here we can see that we are adding environment variable extra latency with the value of 3 seconds. Now let's move on to our next subtask, where we will define our service level objective for product catalog service. For that, let's go to Anthos. Let's go to Service Mesh and click on Product Catalog Service. Now we will go to Health and click on Create SLO. For the metric, let's select latency. We want it to be request based. Let's click Continue. Latency threshold is 1000 milliseconds and click on Continue. Period length should be a calendar day, and our performance goal is 99.5%. Let's click on Continue and create SLO. Over here we see that we are already out of error budget and the value is minus 787.36%. So let's go to metrics for product catalog service and have a look at the graphs. So this is the latency graph. Let's go to cloud trace as well and have a look at the traces. So over here, if we click on any of the dots around 3000 milliseconds, we will see that these correspond to product catalog service. So this is the corresponding call, and if you remember, over here we had the version 2 of our deployment with extra latency added as 3 seconds. Now we know the root cause for our issue. So now let's go back and roll back our release and see if there is an improvement. For rolling back, we will be running these commands. After deleting the version 2 of our product catalog microservice, let's go and check the state of our SLO again. So I'll switch over here. This is the latency graph that we previously visited. It's in the same state. Let's duplicate this page and check the new changes. Over here we will see that the latency has decreased after we deleted the version 2 of our application. And if we go back to health section for product catalog service, we will see that even the error budget has moved towards 0 and is now 607.05%. Let's also go and see the service mesh dashboard that is created for us automatically. So we'll go over here and click on service mesh. We can click on topology, and this is the dashboard. We can adjust it as per our convenience so that it becomes much more readable. So over here we can click on front-end workload node and get the services that are called by this node. In the right pane we get more information about this particular node. So this completes all of our subtasks. That's all for today. See you in the next video.